Hello everyone, my name is Gimhani Hetiarash and I'm a final year software engineering student at University of Westminster. So in this video I will demonstrating the progress of my final year project, Plant Bio. So this project focuses on uh, aggregating and analyzing plant antioxidant and anti-cancer properties data specifically for researchers working in drug discovery. So the key goal is to develop a web-based platform that allows users to efficiently search and filter plant based on species, chemical properties, and geographic origins. So in this demonstration, I will walk you through the current prototype, explain the technical implementation, and showcase how it interacts with Neo4j for data retrieval. So let's get started. And I have implement my project in PyCharm, uh, backend using Python, the Flask framework. So the core motivation behind Plant Bio is to assist researchers by providing by intuitive platform where they can explore plants with medicinal properties. So the platform integrates a Flask based web application with a Neo4j graph database, so allowing efficient data retrieval. Also, currently my focus is on implementing the search and filtering functionality, and future enhancement may include user authentication, data visualization, and research collaboration key features. So, the key features which I implemented is the search interface, where users can enter plant names or phytochemical properties. Neo4j integration allowing users to uh, queries and displaying results in here, and structured dataset containing plants and their scientific classification and medicinal compound. So let's take a code and technical explanation here. So a plant bio is using a framework called in Python, a lightweight web framework called Flask. So handles request, processes user queries, and interacts with Neo4j graph database. The application consists with three main parts: authentication, search functionality, and Neo4j integration. Like here. So the app.py and the base model.py is the handles routing, user logging, and search queries, and templates that contain HTML, which is login, index, and result, and the Neo4j graph database. So let's go through the code breakdown. So in here, as you can see, this initialize the Flask app, which will serve the web pages and handle user requests. And moving on, in here, a function, which means this function loads user credentials from a file. Check if the entered username and password match the stored entry. This allow basic authentication. So moving on, and here there's another function here. This means when a user submits a login details, the system checks if they exist in the user.txt. If valid, they are redirected to the home page. If incorrect, the error message is displayed. So let's move on to another page. So yeah, logging one. In here, this login form is where users enter their credentials. If correct, they are redirect to the home page. And in here, so currently This route loads the results HTML page, but we will extend it to fetch actual data from Neo4j. Other than that, this is the index HTML, and this is the result and CSV file. In here, yeah, in here, this function let's discuss how plant data is stored in Neo4j. So Neo4j is a graph database, meaning data is structured using nodes and relationships instead of traditional database, traditional tables. So here's an example of how plant data is stored. So this function queries Neo4j for a plant is related phytochemicals and returning structured graph data that we can visualize. So let's now go to the live demonstration. Yeah, as you can see, we run the app. As you can see, the server starts successfully, and we access to the web application via a browser. So here's the login page. Since the authentication is basic for now, so users can enter valid credentials to access the main interface. Let's enter password. So after entering the valid credentials, you can access to the search page. Now let's search a plant, say aloe vera. When I submit the query, the Flask backend process, it retrieves data from Neo4j. So as we can see here, the Neo4j, yeah, in here, Neo4j databases returns all stored details about this plant, including its phytochemicals, uh, including its family, uh, and the exact chemical compound. So this confirms that backend is correctly fetching and data from the database. So there are some minor errors I have to implement correctly. So as of as uh, this is the results are displayed on the web page in structured format, making it easier for researchers to analyze the plant properties like plant, scientific name, family, and the phytochemical. And I have in progress with the chemical structure visualization part, data visualization part. So throughout, let's talk about the challenges and solutions which I had faced here. So throughout the development process, I encountered several challenges. Data storage optimization, which is initially planned data was hard coded, but I structured it using Neo4j for the better performance. And next one is the search efficiently. To ensure the fast result, I optimized the cipher queries and indexed key attributes. And the next one is the security concerns. Instead of plain text password, future improvements will improve hashed authentication and role based access. So next, move on to the uh, moving forward, I plan to enhance the project. uh, Moving on to my conclusion. So uh, implementing advanced filtering option to allow researchers to refine searches based on plant families. So I really want to do that. So, and expanding the data set by integrating more medicinal plant and their phytochemical properties, enhancing the UI UX, provide more seamless and interactive user experience, and make it easier to researchers to navigate the analyzing data. Yeah, so as you can see, there's a login back button. So this concludes my demonstration of the Plant by project, and thank you for watching.